All righty. Good afternoon, everyone. Welcome to today's Tech Tuesday on finding data fast in Excel. Today we have with us Doug Cohen, who's the director of our Educational Technologies Group, and basically an Excel whiz. And he's going to be going through a few different types of formulas and functions today to help you kind of navigate in Excel a little easier, and maybe, as the title says, help you find data faster in very complicated Excel sheets. Before we begin, I just wanted to, for everybody who's new to Tech Tuesday, and we do have quite a few people logged in, so I have turned off everyone's mics to prevent any background distractions. If you do have a question at any point, please feel free to type it in the chat. And we'll get to as many questions as we can today. And I'm also recording today's session so that I can send it to everybody who registered later today, as well as some helpful links and guides that you can take a look at and review at your leisure, and even share with some of your colleagues. But without further ado, I'm going to hand it over to Doug. Doug, thank you so much for joining us today.
Thank you so much, Vanessa, and welcome everyone. Happy Tuesday afternoon. So as Vanessa mentioned, we're going to talk through some Excel functions, and we're really going to try to build on a few different functions from beginning to end, so that hopefully by the time we're done with today's Tech Tuesday and with these materials as reference materials, you'll be able to do some more fun stuff in Excel. So let's jump right in and get started, and we'll take it from here. So just to reiterate, this is what we're going to try to cover today. Maybe a little bit too much for a 45-minute session, so we may move pretty quickly, but we're going to focus on formatting text, really just, uppercase, lowercase. We're going to focus on logical operators and, or, and not, because these are going to be very powerful as you start getting into more advanced functions, such as if functions. Just looking at search and substitute, find and replace is always great. A lot of us take text and put it in different tools to use find and replace, and we can use Excel to do that. So that's a good example. Count if and count ifs, just a great way if you have a large data set and you want to look at and slice and dice it a little bit. And XLOOKUP, Excel was really popularly known for VLOOKUPs. There's a newer function called XLOOKUP that allows you to look across multiple sheets or even multiple spreadsheets. And it's really powerful when you're collating data sets across multiple systems. So we're going to try to build through we go. So by the time we get to some XLOOKUPs, they're going to include a lot of the other functions that we've covered. So just a quick start, and I don't know if anyone wants to type it in the chat. I'll leave this up for a few seconds. For anyone who might be familiar with formulas or who's not familiar with formulas, what do these formulas do? And if you're not familiar with them, the good news is that by the end of today's Tech Tuesday, you should be able to write these. So that is really what we're going to try to get to.
We've got functions such as add sum.
So these are functions such as add sum, yes, but these are a little bit more advanced. Sum is one of the functions. These are different functions: if, or, and, concatenate. Someone did nail the grading formula in the middle, and that is one I actually use as an adjunct lecturer, where I use a grade book that is done with a points value, and then we do a conversion to percentage and ultimately letter grade. So let's dive right in, and we'll start to be able to build these in a few minutes. So just in case you haven't spent too much time in the Excel formula bar, I just wanted to quickly let you know that, in the screenshot on the left, you can see what you normally see in Excel, which is the formula bar collapsed. But if you click the down arrow all the way to the right, that is right next to this gray arrow, you can expand the formula bar. And you can also then make it even bigger by clicking and dragging the divider. So as you start to get more advanced formulas that you're writing over multiple lines, just this little trick of being able to expand and collapse the formula bar is really helpful. So I just wanted to point that out to get us started. So I think a lot of us do Excel work, And I tried to create the presentation materials in this structure. So we'll use this first slide to explain. There is an Excel data set. And as you can see, the screenshot in the background, this is actually our team in educational technologies. It was a good data set to use. So we have column A, which is our names, column B, which is our titles. And the first thing I just want to talk about is the different references. So you can see in the zoomed in formula in the table, a relative reference, we simply use equals A2, and that will refer to A2 or cell A2, which is my name. And a relative reference is great when you want to copy and paste cells and have the formula travel with you. So if you were to just drag this formula down, it'll become B2, C2, etc. But you don't always want that to happen. There are times where you want to refer to a cell, but you want it to be an absolute cell. You want it to always refer to that cell. Maybe if you're looking at, numbers and you want to multiply every number by a single percentage, you can create one cell that holds that percentage and then use an absolute reference to it to do the multiplication. So you can simply update the spreadsheet very quickly by just changing that one cell versus having to redo any formulas. So when you do an absolute reference, you do a $sign before the column and a $sign before the cell, the row number. And then in Excel, you can do mixed references where you can make either the column or the row absolute by adding the $sign in front of it. So that's what you see. And you can see, again, A2 refers to myself. The absolute cell A15 refers to Vanessa. And then the mixed A16, in this case, refers to Juliet. And this is structurally how we'll go through the materials. So just a little bit more detail on references. We're not going to spend much time on the written parts of the slides. I just wanted to provide them so as we give you follow-up materials, you have that narrative, and each one of the instructional slides has a link to the appropriate Microsoft documentation in case you find that helpful. So text comparison. As we start doing more and more advanced formulas in Excel, you may want to look at text comparison, because a lowercase letter and an uppercase letter do not equal when you do certain comparisons. So if you want to do something where you want to say, is cell A2 equal to Douglas Cohen in this case, unless you use the proper case as the cell appears, you're not going to get an appropriate response. So what you want to tend to do in these cases is convert everything to uppercase or lowercase so that you can do your comparison. So again, using the same data set, we can see uppercase and lowercase by simply using equals upper and then the cell value, and equals lower and then the cell value. And in this case, you see A2, which was me, I'm in lowercase, and cell A15 is Vanessa, and it's converted them to uppercase and lowercase respectively. And again, the documentation is here should you be interested. So as we start to consider more advanced data sets, because the simple data set doesn't do it justice, this new data set that I'm showing on the screen is just a little bit more advanced. Now we went to 4 columns. We split out first name, last name, seaweed, and email address. And we can start to look at logical functions to start to understand a little bit more of the data set. So, and in logical functions is that each parameter must evaluate to true. So in the case of the first row, it's saying, is cell C2 not equal to null? And is cell D2 not equal to null? And so the only way that that's going to evaluate to true is if both cells, which are C2 and D2, are not null. So they have a value in them, in this case, seaweed and email address. Now, if you only have one of the 2 parameters, as you can see in the next row, it evaluates to false. Not terribly helpful on its own, but very helpful when you start bringing it into larger functions, when you're starting to look at, if this data set is true, then take an action. If this data set is false, then take an action. And you can see the same syntax for OR. We're just going down the data set on the left, but OR is very different. If you have 2 clauses that you're trying to evaluate, only one of them needs to be true. So if we look at row 4, we can see that there is a seaweed and email address. That's going to be true. But if we look at row 5, we can see that there's a seaweed, but no email address. That's also going to be true when you're using the OR function. And then in the last one, for row 6, they're both blank, so that's where it becomes false. Just to, there's a question in the chat. Yes, we will send a copy of the presentation materials and also an Excel spreadsheet with all of this, with the actual formulas, so you can see them live. Another one that is really important is, as you start looking at the logical functions, is sometimes you need to do the reverse. You need to look at the not function. So you want to evaluate something, and maybe it comes out to be false and you need it to be true. So you can evaluate something, as you see in this bottom row here. We have an OR function for whether cell C6 doesn't equal null and D6 doesn't equal null, but then we want to find the not value, the inverse value. So it flips it to true. So again, as you think about your logical sequences when you ask these questions, if something, then what happens, or else what happens, these become really valuable. And again, we're going to build on these in a few minutes. So again, just following up, a lot more details on learning about the OR and not functions in Excel. So find and replace. I think we all use find and replace. I know I'm a Mac user. I tend to put a lot of text in text edit and then use the find and replace tools because I find them really easy to use. However, once you start to know Excel formulas, there's a formula that can do it for you. So what you see here in these two screenshots, the back screenshot is really just the data set. So we have some videos in our video system at the institution, which is called Panopto. And we used to reference Panopto using the website address stream.weil.cornell.edu. However, as the system has been enhanced, we've now changed it to a cloud service, and it is weilcornell.hosted.panopto.com. So this is a great use of substitute, where you can find all your old website addresses and simply use the substitute function to replace stream.weil.cornell.edu with the new URL. So you see weilcornell.hosted.panopto.com. So by running this function against the data set, we're able to create the new URLs very quickly, and we were able to have them handy. So while this was a small sample of only 3 rows, this function is very quick. You can use it against thousands of records, and it would be something that if you want to use find and replace, you could look to Excel to do. And same structure, continuing on with documentation. So searching in Excel is honestly a bit awkward. So I just want to spend a little bit of time explaining the search function. So searching can be great, but you really have to understand the way the results come up. So if we look at the data set that we have in this screenshot, again, it's back to the educational technologies team, and we have our names and our title. And you can see that we have 4 examples. 2 are formulas that are using search to search for the word specialist. And again, noting what I mentioned earlier, you notice that I have the capital S because that's how it appears in the slides. And the first row returns a 16. And what that is telling you, that is the word specialist was found, and it was found at position 16. Now that may or may not be helpful to you. I know I don't tend to use the number, but it does tell me that yes, it was found, and it was found at the 16th position in that cell. And you can then use that in a lot of ways, whereas the second row is also searching for the word specialist in cell B2, but I don't have the word specialist in my title. And the search function throws this, the dreaded pound value exclamation point, the dreaded errors in Excel. So searching becomes a bit of a tougher function to use, because if you find the value, you can work on it very easily. If you don't find the value, it actually produces an error, and you have to be able to catch that error to act on it. And we will talk about that. So the same using searching for the word support. You can see that cell B24, we found it, and in cell B10, we did not, and it produced an error. So again, using this, we can create more complex formulas as we go forward. So search function, here's the documentation. So COUNTIF and COUNTIFs really do what they say. So if you want to count a single criteria, you would use the COUNTIF function. And if we highlight the first row here, we are using COUNTIF against the column of B2 to B11. So this is the different workplace classifications. And we're actually searching for the word hub. But I just used one of those absolute references that we also talked about earlier. So you can see that instead of typing the word hub in the formula, I'm reusing the value that I have in the spreadsheet. And you can see that we have 2 people on our team that are identified in this, team members 1 through 10 that are identified as hub. And then count ifs does the same thing, but allows you to put more criteria in there. So in this case, we're searching the same data set, which is column B, rows 2 through 11. We're searching for E4, which is going to be hybrid home. And we're also searching for the C column for office D008. So this formula, you can see we have both parameters for the ifs, and one I'm using an absolute reference and one I'm actually typing in the text. And what this really returns for you is to tell you, okay, we have 2 team members that are hub, and we have 3 team members that are classified as hybrid home in the D008 office. And so this could definitely work depending on your data set.
Hey,
So
Doug,
there's
you got a couple. Oh, sorry. I think you just saw them.
Go ahead. Why don't you take them and I'll answer them.
Sure. We just got a couple of questions. Can you do a count if to find all mentions of the word hub that are in a column, even if the word isn't alone in a cell?
Yes, you could. You could actually, you would want to do a search for it and then do the count if of that. So you would have to nest a formula, but you could absolutely do it.
And why do you need absolute references in count if?
So you don't need absolute references. One is, as I was trying to create materials, I was trying to build on the prior materials. But one of the things in general, I think, as you write formulas, anytime you put a specific text string in a formula, you then have to remember that you have a specific text string in the formula. So that's number one. So I try to avoid that as much as I can by using references. The absolute references, the only reason to do an absolute reference is that you wouldn't want it to change. And so what I do in a lot of formulas, and maybe it doesn't make sense in this example, is I create spreadsheets that have settings. And so you might go to the first sheet of a really advanced spreadsheet that has settings, and you would put those settings in individual cells. And then you would refer to that using absolute positioning or absolute referencing. And this way, as you change the settings once on the settings tab, all your formulas know to refer to that. And if you copy paste the cells or do anything on the back end, it really won't change it. That is the true power of absolute references. In these simple ones, it really does not add any value. All right, and so we have documentation on count if and count ifs. And as I mentioned, as you start using these functions more and more, you really need to get a little bit into error handling. And so there's an is error function, and then we're also going to talk about an if error function. So is error simply looks at a cell value and evaluates it to determine if it's an error. So if you look at this data set, we're using capacity versus allocation data. So we're saying, okay, your capacity as an employee is 35 hours per week, and maybe you've been allocated to 35 hours of projects, 40 hours of projects, 0 hours of projects. And so if you look at the allocation column here, you can see I tried to do that in a couple different ways. And then we're simply running a percentage formula, which is value 1 divided by value 2. And you can see that Excel produced a couple of errors. One is the division by 0 error, one is the value error. And so we can use is error to look at that and say, did that formula produce an error? And so if we look at cell D2, we have 100%. That returns a false because it's not an error, it's a valid percentage. However, cell 3, you can't divide by 0. So is error is true because it is an error. And now this gives you the option, again, true and false isn't terribly helpful in something on the user side. But if we can take that and say, if it's an error, what do we want to do with it? And that's what we're going to focus on in the next slide or two. So if we look at if error gives us a really nice way to trap errors and do something else. So it's very similar to the is error, except it has an additional parameter that you can then take an action. So using the same data set, I've now just added this second clause here that says check for valid equation. So instead of showing up as a divide by zero error or a value error, it gives us a prettier error message, check for valid equation. So we can go look at the data set and find what the error is versus seeing the error. Now you don't have to do a message here. I just chose to do that for the demo. You could then use a different formula to rewrite the equation. So instead of saying check for valid equation, you could have a different formula in here to actually do a new math equation. So really powerful once you start to understand how to trap these errors and do it. Now, if statements can be done for error handling, but they can be done in lots of different ways. So, if then else is your generic if statement functionality. And I continued the trend in this slide just to show the error handling. So if there's an error, take an action, otherwise take a different action. So you can see we have the first one, we're looking, is there an error in D2? And that would evaluate to false. So it's going to then turn around and show us the data set. So this is a way to trap it. Now you don't have to do it that way. You can turn around and say, if there's an error, when it's true, use another formula. So you really have a lot of power here, and you don't always have to do error checks. In some of the examples I have, and I have one later, we look at cells to say, is there a value in the cell? And if there's no value in the cell, then go look up to another sheet to go find a value. So it really is a very powerful function, and nested with everything we've talked about, uppercase, lowercase, substitute, search, you really can start to do some powerful things. And that's really going to take us into the last function I wanted to cover, and then maybe we'll hopefully do some either live demo or Q&A, is XLOOKUP. So an XLOOKUP really just looks up data either across another sheet or in different columns. So while this data set on the screenshot looks very similar to what you've seen in the other slides, it was actually created very differently. So we have a name column, column A, which was embedded in the sheet. Column B for title is actually using XLOOKUP to look up against a different sheet. And in this case, I have a sheet in the workbook called search. And column C to get seaweeds is also done against a different sheet. And so really powerful to turn around and say, okay, I only had first name, but I know in a different data set, I was able to then start parsing and grabbing the data elements I need. And you can use XLOOKUP for that. So the syntax, XLOOKUP, the criteria you want to search against. So in this case, cell A6, we'll pick on Ron Lemise. And then it's going to the search worksheet, column A, that is the key. So it's looking for Ron Lemise, this value in the search worksheet, column A, and then it's returning the value in column B when it finds it. And so you can see in the case, it returns Ron's title, which was sysanalyst. So that's great, but sometimes you need to do even more advanced lookups. And what I wanted to showcase as sort of our final lookup formula is a bit more of an advanced one. So first, we put a lookup inside of an if statement. So we're doing an if, and then we're doing a lookup. So the lookup is trying to find a value. And then if it doesn't find the value, it's going to tell you that there's a not found. But if it does find the value, it's actually going to use the value that it found. So this gives you the ability to look against a different sheet, determine if you see or don't see the value, and then either use the value or use an error message. And then, as I mentioned before, nesting functions becomes really important. Not only is there a nested XLOOKUP inside of an if statement, you might see that I have this little function here, which is left A7 find space. All that is saying is use the A column left of the space. So instead of actually using an entire cell value, I was parsing individual names to split between first and last name, and then using the first name to do a lookup. Again, I wouldn't do a lookup against a first name in a real data set. I would use an email address or a seaweed or something unique. But this really does showcase the power of nested functions and what you can do with them. And that is going to be the documentation on XLOOKUP. And I'm going to pause here for questions, because that's really the major functions I wanted to cover. And then I can definitely go into a little bit more detail.
We just got a question. Could you explain the difference between an XLOOKUP and a VLOOKUP?
So they're functionally similar. VLOOKUP has been in Excel for ages. And the difference with VLOOKUP is you have to have more exact values. So you have to look at a different column and identify the value of the data you want to key on. What's really nice about XLOOKUP is you can key on columns. One, it's actually much simpler to type. XLOOKUP, you need 3 parameters. You need the lookup value, the lookup array, and the return array. So your lookup value tends to be a cell, right? You say, I want to key off this cell, someone's seaweed, someone's whatever. And then when you look against the other sheet, you can just simply say, grab column A as the lookup value, the lookup array, and grab column C as the return array. And it will then do all the work for you. It will find the lookup value in column A and return the value in C. So functionally, the results are the same. But as you start practicing with them, XLOOKUP is way, way, way easier to use. So that is actually why I focused on XLOOKUP versus VLOOKUP. XLOOKUP is the new version. It really, they can be used interchangeably, but over the last year or two, I've really only used XLOOKUP and stopped using VLOOKUP. So I hope that helps explain a little bit. All right.
Did you get a request if you could demonstrate how you created that XLOOKUP example?
Okay, so Vanessa said that kind of request was coming. So this is one of the things we're going to share as an output of the session. So let me just give you a quick rundown of it. Everything you saw in screenshots is from this spreadsheet that I created as a reference. So each of the functions you see in screenshots corresponds to a tab. So you're going to see a data set. We did references, we did case, logical operators. So I have an XLOOKUP worksheet, and I'm really just going to grab one, and we'll actually write a lookup. So to start any formula, you do your equals, you type your function, and it's gonna tell us XLOOKUP. And you can see Excel is great. It gives you the help. The lookup value, we're going to grab a cell. In this case, we're going to grab Cynthia. And then you're just gonna add your comma. Now lookup array. So we have to figure out, what do we want to look up against? And we could actually do it all from one sheet. So what we want to look up against is, we know that Cynthia's name as a key is in column A. So we're going to look up against that column. And what do we want to return? We want to return the seaweed that is found in column C. So then we can just say column C, and then close your function, and that's going to return a seaweed. It really gets awkward when you do this on one sheet, because why would you do that on one sheet? So I'll do the same thing, but just bear with me. I will find, we'll use references. We'll go across a different sheet now to do a different type of XLOOKUP, but functionally it's going to be exactly the same. We're going to do an XLOOKUP, and our lookup value, we will also use Cynthia. We're going to hit our comma. Now it's going to tell us go and find the lookup array, and we're going to go to the references tab. And we know that Cynthia Morel is going to show up here. So we're going to choose column A as the lookup array, and we want to return Cynthia's title. And now you can see in the formula bar, it has the sheet, colon, columns. So you see we're pointing to references, column A, references, column B. And now when I save this, it's going to pull the title from a different sheet. And so XLOOKUPs become really powerful when you start having different keys. And on the academic side, I know, and other departments I'm sure face the same thing. We have seaweed as an identifier. We have email address as an identifier. But there's other identifiers that are in use across all the different systems. Maybe it's employee ID. In the academic side, maybe it's the Genzabar ID. For students applying to medical school, it could be their AMCAS ID or the AAMC ID. So what you can do is have sheets with all those independent data sets. And then as long as there's the seaweed across all of them, you can start looking across all of the data sets. So that's a live XLOOKUP.
Thanks, Doug. We had a question about what's the benefit of XLOOKUP versus index?
Honestly, I would have to take that one back and take a look at index. Index is not one I use often, so I will follow up with that question. We'll
Sure,
provide that.
I'll send you the transcript so you could see who asked it. And then how would you use XLOOKUP to collate a table?
Well, I'm not sure when the question is asking collate a table. So this is actually an example of using XLOOKUP in my mind to collate a table. I don't know if you're talking about a specific table function in Excel as in format as table. But this is where this data set, you can see column B is actually all generated, from XLOOKUPs if you look at the formula, and so is column C. So you really could create this as a table. I mean, we could just take this and do format as table. I don't really want to save it. So I'm not going to save it because it's definitely going to change the spreadsheet that I'm going to share. But we just took and now created an Excel table that we have all the sort functions and filtering functions that you would want in a table, but all the data is populated via XLOOKUPs. So you functionally would do it exactly how we talked about, and then you would just hit format as table for your result set. If that answers the question. And do we have any additional questions?
We did have a comment about, just more interest in the difference between XLOOKUP versus VLOOKUP. So I'll try to go into some of Microsoft's guides to see what I can send to everybody in the follow-up messaging. And then there's a comment here. I'm also interested in the major differences as I need to create documents with and without macros based on sharing function.
So that's a great question. So actually everything I showed is done in formulas. There is no macros. And for sharing is exactly why I spent the time creating the formulas versus any macros. This spreadsheet could be shared, and we will share this spreadsheet with you. And all the formulas will go. You will not get any warnings about any malicious macros attempting to run. And we could absolutely help if you had some questions about but that's exactly why using formulas versus macros does make the sharing much easier.
We just got one. How do you use indirect cell references such as address? I think we might need more information for that one, Frank.
Yeah, I'm just trying to read the question. Give me 1 second. Okay, so the question is a long list of mailing addresses and only wants to select a certain zip code to create a smaller spreadsheet. So there would be a bunch of ways to do that. And it's definitely going to run past time today. But you could actually do it with lookups where you could have, say, 5,000 records in a mailing list. You could create a new tab and do an XLOOKUP where you keyed off the zip code and then returned the values for those rows with that zip code. So you would end up creating a second sheet, but the second sheet would immediately be restricted to the zip code because you used XLOOKUP against the zip code. That is one way to do it. I'm sure there's other ways to do it. I'm happy to attempt to help if that is a data set that you could share with me and we could do as a follow-up. And so the last question that Vanessa mentioned, how to use indirect cell references, I address. So let me just quickly share the Excel sheet one more time. So the references, you know, there's reasons to do them, but this data set, well, actually this data set is a little bit better to explain why you would use different references. So I mentioned in my spare time, I am an adjunct lecturer, and this is an example of a grade spreadsheet that I would use. So, you know, student name, in our case, seaweed, student ID. Here's the grades for the different assignments in the course. Here's the total points. We convert that to a percentage. We convert that to a letter grade. So here's when I started talking about the settings. The settings in this case are what are the maximum points for the course, because we want to be able to take for every student, we want to take their points achieved against the maximum in order to create a percentage. So if you look, as I have this cell highlighted, I'm using a reference to an absolute positioned S2. And the reason you do that is because when you copy paste cells with absolute references, the formula, and you see I just created 3 new rows, and I will highlight them just so we can stay and look at them. So the formula stays pointing to cell S2. Now I'm going to take that same row and I'm going to use a relative reference, and you're going to see what happens when I paste it. So I'm going to change this to simply point to cell S2, and you'll notice it still worked great. Except the problem is when I copy paste the relative reference, it now wants to use relative, and it now turned this formula to cell S3, and it turned this one to cell S4. And so when you create these sorts of settings, and a gradebook is a good example of that, absolute positioning for the max score makes sense. So as you copy paste rows and manipulations, it always uses the same fields for max score. So, you know, very quickly, if I were to say that this was out of 800, watch the percentage column. It updated everything very quickly. So I hope that explains why you would use the absolute reference versus the relative. There's definitely points where you want relative references. When you want to write a formula, you know, if you were writing this formula here, and you can see as I expand the formula bar, we're looking at cell O2 and really determining, is it, you know, 94 or better, between 90 and 94. You want these all to be relative because you want to be able to simply just take this and drag it down. And now the second one looks at O3 and then O4. So it's a mix and match technique, but that would be why you would use absolute and relative. So any last questions? Well, if not, thank you very much. I will just screen share very quickly. I just want to plug, well, just to put it all together, this is what we talked about. Here's some examples of formulas that tie everything we've talked about together. And this larger formula here on the bottom is one that we used recently in an academic setting where we were looking at students picking appropriate values in a multi checkbox, you know, check all that apply. And depending on which ones they checked in that, they would get a point value. So it's just an example of that formula and how you would accomplish that in Excel. And to close, I do want to plug, you know, we have the tip up on Excel for formatting using trim and clean. So if you're not familiar with that tip up, it's a great one to watch. And with that, I will close and answer any last questions. So the last question I saw, can we have additional trainings like that with more examples? Also, maybe a closer lookup at VLOOKUP or XLOOKUPs. If my colleagues would like to have me back, I would be happy to do that. But I'll leave it in their hands for scheduling that.
Thanks,
So
Doug.
thank you,
Also,
everyone.
I wanted to point out to Patrick, that's a great question. We do also have access to services like LinkedIn Learning that do have on-demand courses on a ton of applications. There's actually a few great Excel courses on there where you can actually go in. You don't have to take the entire course, but if you wanted to look up specific videos about XLOOKUP or VLOOKUP or any other function in Excel, I can certainly add links to those in the follow-up email. So you can actually take a look whenever you want, and you don't have to wait for us to, hopefully schedule something in the future. But, it also would have really great demonstrations of how you can use those functions for any work that you're doing.
Well, again, thank you very much, everyone.
Thanks, everyone. I'll send the follow-up information later today. Have a great rest of the day. Thanks, Doug.